So I wanted to take a few minutes to review how to graph a line. This is a review of a standard called A.REI.10, and this is the explanation to the practice test on my website or on our Canvas page. So a couple of things to remember, just a quick review, that functions come in a lot of different forms, but one that is really helpful is the y equals mx plus b format. And what that means is we're going to take coordinates x and y, and we have two pieces of information other than the x value and the y value. We know that the m is the slope. Sometimes we call that the rate of change. And sometimes we call that rise over run, which is the same thing as the change in the y value versus the change in the x value. And they're really interchangeable. These three ideas can replace one another. Well, there's really four ideas here. So that's what the m part means. And then we've got our starting point. And that is our b, so we're going to call it the starting point. And it's also known as the y-intercept. So both of these terms, starting point and y-intercept, would describe the b value. So if I'm over here and I'm looking at this equation, I notice a couple of things. I notice that it's in this y equals some number x plus some number form. Well, the y is the y value. The m is -2 here, so the slope is going to be -2, or the rate of change is going to be -2, or the rise over run is going to be -2, and I spelled run wrong, clearly. The rise over run is going to be -2, okay, because it's in the same position as the m. And the starting point, the b value, is +3, and it's the starting point, or it's also known as the y-intercept. So if I know that this equation comes in the form of y equals mx plus b, my m value is -2, and my b value is 3. Well, we run into this issue. How do I get a rise over run out of a whole number? Any number can be divided by 1. So this is -2 is the rise, and the run is 1. And b is our starting point. And so that means 3 is our starting point. So on my graph, we're going to plot the point 3 because it's on this y-intercept. It's where it crosses the y-axis here. So 3 is my starting point, so I plotted that there. And then my rise over run is down 2 because it's -2, and over 1. So we're going to count down 2, 1, 2, and then over 1. And we're going to plot a point there. So plot a point down 2 over 1. We're going to go down 2 more and over 1 again. And we're going to repeat that process until I reach the edge of my graph. And you can use a straight edge or a ruler to connect those with a straight line. But essentially, you're going to be drawing dots all the way to the edge of the page until you get all the way to the edge. So that's how to graph the basics of graphing a function that comes in y equals mx plus b form. Well, here's the challenge, is they don't always come in this y equals mx plus b form. Sometimes they come in something called standard form. And standard form is when the numbers are kind of in different places. And my recommendation to students when you have this problem is to change it into a different format. So what I'm going to do is I'm going to show you kind of with the same idea. We want it to be in this y equals mx plus b. That's ideal. That's our ideal place to be. And right now, this is currently not in that format. So we need to use some of our solving skills that we've been working on in previous units to be able to graph this well. So currently we've got 2x minus y equals -2. Well, I need the y to be on one side, and the mx to be on the other. Right now the mx is on this side, so I need to move it over by using a balanced move to move it over. So I'm going to subtract 2x from both sides because that's a balanced move. I can take 2x's off of both sides. And that cancels out. I'm left with negative y equals negative 2x minus 2. Now it looks really close. It looks really, really close because it looks like I've got y equals mx plus b. It looks like I've got mx and it looks like I've got b. The problem is I don't just have y, I've got negative y. So we got to divide by negative 1 or multiply by negative 1. I like to divide here. And I got to divide everything by negative 1. So now we have negative y divided by negative 1 is y equals negative 2x divided by negative 1, 2x, and negative 2 divided by negative 1, positive 1. So now I'm going to graph this where my starting point is the b value, the 1, and the slope is 2, or 2 over 1. So my m is now 2, and my b is now 1. So I'm going to start at 1. My rise over run is 2 over 1, because 2 divided by 1 is still 2. So up 2 and over 1, up 2 and over 1, up 2 and over 1. We're going to continue all the way to the edge of the graphing area and connect all of those dots with a straight line. And I'm not doing a very good job going through the points, but you get the idea. So if we don't have it in y equals mx plus b form, we need to make it into y equals mx plus b form. And hopefully you see that this is in y equals mx plus b form. Okay, and we're going to go to the next page. So again, we run into the same problem, is we don't have it in y equals mx plus b form. I'm going to write that up just to be helpful. We want it in this format, y equals mx plus b, and right now it's in not that. 4y equals 3x minus 24. So I think to myself, what do I got to do to make this 4y equals 3x plus 2? How do I make that into y equals mx plus b? Well, the only thing that's really gone wrong here is this 4 multiplied in front. So divide by 4. And when we do to one side, we've got to do to everything on the other side. So I also have to divide by 4. I also have to divide by 4. Well, that doesn't leave us with a pretty picture because the 4's cancel out really nicely, and I'm left with y. But 3 divided by 4 is not a very nice number, and I like a fraction there, actually. So I'm going to leave it 3/4 x, because 3 divided by 4 is 3/4. And negative 2, oh, my goodness, I copied that wrong. It's negative 24. My bad. Negative 24 should be negative 24. Okay, so negative 24, that makes it really nice because negative 24 divided by 4 ends up being negative 6. So when I go graph, I've got my slope, I've got my m, my slope, and I've got my starting point. My b is negative 6. It's going to include the sign in front of it. And the slope is it's positive 3/4. So my starting point is negative 6. So on my graph, I'm going to start at negative 6. And my rise over run is up 3 over 4 because it's rise divided by run. So up 3. So I'm going to count 1, 2, 3 over 1, 2, 3, 4. Up 3, 1, 2, 3 over 1, 2, 3, 4. And I plot big dots to help me know where it's at, and then I connect them. And hopefully you'll do that with a straight edge or a ruler. Okay. So, that helps with these. The last question on this particular assessment is, if you select all of the solutions to the following linear equation. There's 2 ways to do that, and you kind of have to go back and remember what it means to be function notation. We've got an input and we've got an output. So our input is the first number, it's our x, and the output is the y value or the f of x. So it's either called y or it's also called f of x. And so, sometimes we call it y, sometimes we call it f of x. Doesn't matter too much. But the x value is the first number, the f of x or the y value is the second number. So in our graph, if we start plotting, I'm going to plot them in different colors so that you can see. My x-coordinate is the first coordinate. The y-coordinate is the second one. So if 0, 6, x is 0, y is 6, is it a solution to the function? Well, yes, it's a solution because it's on the line. So we'd say, yes, A is a solution. I'm going to do the second one, where the x value is 6 and the y value is 0. Well, that means that the x value is 6, the y value is 0. That's this point on the graph. Is it a solution? Is it on the equation? No, this is not a solution because it's not on the graph. Do a couple more here. -3, -7. So the x value is -3, the y value is -7. That's all the way down here. That is clearly not a solution. Gonna switch my pencil color. We're gonna do D in orange so you can see -6 and +8. So I'm gonna go -6 and +8. It's on the graph right there. The x value is 6, the y value is +8, and that is a solution. Yep. Take a look at the next one. Let's do like a purple. So we're gonna do purple. So 3 and 5. So right there, is it a solution? Yes, it is a solution. Now here's where we run into the major problem, is knowing, is this last one a solution? And I'm going to do it here in black, and this is where this comes in. So if I say f of x, the function with an input of x, has -1/3 of that x value plus 6, do I get 18? So if my y value is 0 in this case, and my x value is 18 because the x value is 18, the y value is 0, so f of x is the y value. Remember that. So the y value is 0. What's the x value? 18 is -1/3 times 18 plus 6. Is that 0? And then I'm going to have to do a little bit of just arithmetic. It's got to use the order of operation, so multiplication first. We're asking, is 0 equal to that? Is 0 equal to -1/3 times 18 is -6 plus 6? Is 0 equal to -6 plus 6? Well, yes, 0 is equal to 0 because -6 plus 6 is 0. So yes, it is true that 18. And if we continued this line, to keep going and we had all the space in the world and we were able to continue the grid, we would see that at the point 18 and 0, this line would be on that point. I know this is a lot. My recommendation, this skill incorporates a lot of different standards, particularly solving. You have to know how to solve in order to access a lot of these questions. Please revisit our class course to review how to solve, to be able to access many of these problems. I hope this was helpful. Please email me if you have any questions at all regarding how to solve these problems. I want to be available for you, but this is a challenging skill overall.